Before a hacker ever touches your network, they study you, your website, your LinkedIn, your job posts, your PDFs, old subdomains, and breach passwords. But now there's a new accelerant, AI. A few years ago, an attacker had to manually connect all those dots. Today, they can feed public information into an LLM and ask it to summarize your company, identify likely targets, infer your tech stack, and help write a believable pretext. That's the scary part. AI doesn't need to hack you, it just needs to make the research phase faster, cleaner, and more convincing. So today I'm going to look at my own business the way an attacker might, using public information, traditional recon tools, and AI to connect the dots. And then I'll show you how to defend against it. This is called OSINT, Open Source Intelligence. It's the reconnaissance phase of an attack. Everything I'm showing is legal and defensive when you do it on your own company, your own domain, and systems you're authorized to review. Do not use this to target other businesses. The goal is simple. If I can find it, an attacker can find it. And if an attacker can find it, AI can help them organize it, summarize it, and weaponize it faster. So for each step, I'll show you three things. What's public, how AI makes it more useful to an attacker, and what you can do about it. The first tool is still Google. I'm looking for public documents, PDFs, old pages, email addresses, employee names, vendor references, and anything that reveals how the company operates. A PDF might include names, titles, document authors, software names, internal terminology, or an email format. By itself, that may not look dangerous. But now imagine an attacker copies the public findings into an AI tool and asks it to summarize patterns. Not secrets, patterns. Who works there? What departments exist? What vendors are mentioned? What email format does the company appear to use? What language does the company use publicly? That gives them a better map. This is why the problem isn't one leaked PDF. The problem is aggregation. AI is very good at taking 10 boring pieces of public information and turning them into one useful profile. Next, LinkedIn. LinkedIn is basically a public org chart. You can find executives, finance people, HR, IT, operations, sales, and new hires. Attackers care about different people for different reasons. Finance can approve payments. HR opens attachments. IT has authority. New hires don't know what normal looks like yet. Now add AI. An attacker can take public LinkedIn information and ask an LLM to summarize likely reporting lines, identify high risk roles, or suggest who might be targeted for impersonation. I'm not going to demonstrate writing a phishing email because that's not the point. But this is what matters. AI can make a fake message sound less fake. It can match tone. It can reference the right department. It can make the timing feel normal. It can turn public context into a believable story. That's the shift. The attacker no longer needs to be a great writer. They just need enough public detail for AI to help them sound credible. Job posts are another huge source of information. Companies often list the tools they use: Microsoft 365, Google Workspace, Okta, NetSuite, AWS, CrowdStrike, etc. From a hiring perspective, that makes sense. From an attacker's perspective, it tells them what kind of fake notification might feel real. And from an AI perspective, it gets even easier. An attacker can paste a job post into an LLM and ask, what technologies does this company likely use? What departments rely on these tools? What business processes might be connected to them? Again, the danger isn't that the tool names are public. The danger is that AI helps connect those tools to believable attack scenarios. Next, I'm checking public certificate records and subdomains. This can reveal things like dev.company.com, staging.company.com, portal.company.com, and others. Some are normal, some are forgotten, and forgotten internet-facing systems are exactly what attackers love. AI can help here too. An attacker can collect a list of subdomains and ask an LLM to categorize them. Which look like login portals, which look like development environments, which look like remote access, which should be prioritized for manual review. That doesn't break in by itself, but it speeds up the attacker's triage. The human problem is still the same. We'll take that down later. Later becomes 6 months. 6 months becomes 3 years. Then somebody else finds it. Now I'm looking at what services are exposed to the internet. For your own authorized systems, tools like Shodan can show whether remote desktop, VPN appliances, admin panels, camera systems, or file transfer services are visible. Attackers can use AI to interpret what they find. If they see product names or version banners, AI can help summarize what service that is, why it matters, and what kind of risk it may represent. For defenders, the same capability is useful. You can take your own inventory and ask AI, what should I prioritize closing first? What looks like remote access? What should be behind a VPN? What questions should I ask my IT provider? That's the good use of AI here. Use it as a second set of eyes on your own exposure. Next are breach credentials. A service like Have I Been Pwned can help domain owners understand which company email addresses have appeared in known breaches. The danger is password reuse. If an employee used a work email on an old site and that site was breached, attackers may have an old password. AI doesn't need the password to be useful here. It can help attackers prioritize. Is this person in finance? Are they an executive? Are they in IT? Are they new? Do they appear in public company posts? That helps attackers decide where to focus. This is where MFA matters. You cannot hide every email address. You cannot undo every breach. But you can make stolen passwords much less useful. Strong MFA on email, finance tools, cloud apps, and remote access is one of the highest impact defenses you can put in place, especially email. Email is the control room. Protect it like one. The last category is social media and metadata. Office photos can reveal whiteboards, badges, screens, internal tools, floor plans, shipping labels, or project names. Documents can include metadata like author names, usernames, file paths, software versions, or timestamps. AI makes this more scalable. An attacker can collect public posts and ask AI to summarize. Who appears often? What tools are visible? What events are happening? Is leadership traveling? Are there new hires? Again, one photo is usually not the issue. The issue is the pattern. AI is very good at patterns. Now let's chain it all together. An attacker spends 30 minutes researching a business. They find the email format from public documents. They find the finance manager on LinkedIn. They see a new operations hire started this month. They find job posts mentioning Microsoft 365 and a payroll platform. They discover employee emails and old breaches. They see from social media that the CEO is traveling this week. Then they use AI to organize the findings. Who is the likely target? What pretext would feel normal? What software should the message reference? What tone does the company use publicly? What timing makes sense? Then the attacker sends a believable message. No malware, no genius, no hoodie in a basement magic. Just public information, AI-assisted research, and trust. That is the modern threat. So what do you do? First, don't try to hide things that can't realistically be hidden. Your email format is not a security control. Your employees being on LinkedIn is not the root problem. The fix is resilience. Use strong MFA. Require out-of-band approval for payment changes. Train employees to verify unusual requests through a second channel. Limit what job posts reveal when possible. Remove stale subdomains and old portals. Put remote access behind secure controls. Monitor breach credentials for your domain. Create simple social media rules. No badges, whiteboards, dashboards, shipping labels, or sensitive screens. And use AI defensively. Take your own public information and ask, what could an attacker infer from this? What sensitive details are we exposing? What should we clean up first? What policies would reduce this risk? Just don't paste private company data, customer data, secrets, or credentials into public AI tools. Use public information only, or use an approved internal private AI environment. Here's your action item. Take 15 minutes today and run an AI-assisted self-recon on your own business. Check 6 things: Google results and public documents, LinkedIn profiles and job posts, subdomains and certificates, exposed services, breached credentials, and social media and metadata. Then use AI defensively. Ask it to summarize your public footprint, identify the riskiest categories, and recommend the first 3 fixes. Write down the worst 3 findings. Fix 1 this week. That's it. Security improves when you build the habit of seeing your business from the outside. I automated this outside-in view because most business owners don't have time to manually check all of this every week. ThreatScope scans your domain for free in about 30 seconds. No sign-up required. It gives you a quick look at what your company is exposing so you can find the obvious issues before someone else or someone else's AI does. You will find the link below to ThreatScope. And if you want to see the first video in this series, I'll put it on screen here. Subscribe for more practical security breakdowns for real businesses without the fear-mongering. I'll see you in the next one.